All right, let's dive right in. Today, we're cracking open the calculus toolbox to tackle one of its biggest puzzles, limits. If you've ever found yourself just staring at a problem, not knowing where to start, then this is for you. We're going to build your limit-solving skills one tool at a time. Let's get to it.
I get it. You look at a page of handwritten notes like this with all the fractions and weird symbols, and it can seem pretty intimidating. But I promise you, by the end of this, you won't see a problem anymore. You'll see a puzzle, and you'll have all the pieces you need to solve it.
So here's our game plan. We're going to start with the easiest method, the one you should always try first, substitution. Then we'll face the big boss, the dreaded 0 over 0 problem. After that, we'll build out your toolkit with some heavy-duty methods, and to wrap it all up, I'll show you an awesome shortcut for some very specific situations.
Okay, so every good toolkit has that one essential go-to tool, right? The screwdriver you grab for almost everything? Well, in the world of limits, that tool is direct substitution. It's your first move every single time.
You know, the idea here is actually beautiful. If a function is behaving nicely at the point you're looking at, so no weird gaps or jumps, then the limit is literally just the value of the function right there. When this works, it's the absolute fastest way to get your answer. Let's look at a real example here. To find the limit as x gets closer and closer to 1, you just replace every single x with a 1. That's it. You do the math, and boom, there's your answer. It feels almost too easy, right? But what happens when it doesn't work?
And that question right there brings us to the real heart of solving limits. What do you do when the easy path leads you straight to a dead end?
Okay, take a look at what happens in this third problem. We try our trusty substitution method, we plug in 2 for x, and what do we get? Well, 4 minus 2 is 0 on top, and 8 minus 2 minus 6 is also 0 on the bottom. We get 0 over 0. Uh-oh.
This, my friends, has a special name. It's called the indeterminate form. It's basically a mathematical smoke signal. It doesn't mean the answer is 0, and it doesn't mean it's undefined. It's the function's way of telling you, not so fast, the answer is hidden, and you're going to have to do a little more work to find it.
So when you hit that 0, 0 wall, don't panic. It's just a sign that it's time to open up the real toolkit. We're about to arm you with 3 super powerful techniques to break these problems down and figure out what the true limit actually is.
Our first tool is a classic straight out of algebra, factoring. It's all about rewriting the expression so we can find the piece that's causing all the trouble and, well, get rid of it. The process here is super straightforward. First, you break down the top and bottom of the fraction into their factors. Then, you'll spot a common piece. That's the troublemaker, the thing causing those zeros. You cancel it out, and then you can go right back to our easy substitution method with what's left.
Let's see this thing in action. In problem 6, if you plug in 4, both the top and bottom become 0. That's our big clue. It tells us that x minus 4 has to be a factor of both. And look, once you factor it out, you can cancel those terms. And just like that, the problem is unlocked. Plug in 4 and you get your answer, 8.
But factoring isn't a silver bullet. It doesn't always work, especially when you see a square root in the problem. For that, we need our next tool, the conjugate method. Now, conjugate sounds like a fancy word, but it's simple. You just take the same expression and flip the sign in the middle. Multiplying by it is like magic for getting rid of those tricky square roots.
And the game plan is pretty much the same. Find the part with the square root, multiply both the top and the bottom by its conjugate, and that's key, you have to do it to both, and then simplify everything. The problem factor will pop right out, you cancel it, and then you can substitute to find the limit.
Check out problem 5 right here. It's got a square root, and direct substitution gives us 0 over 0. So what do? We multiply by the conjugate. We take the numerator, flip that minus to a plus, and multiply it on both the top and the bottom. That clever move totally transforms the numerator into x minus 7, which then perfectly cancels with the x minus 7 in the denominator. Problem solved.
Okay, so we've covered the hand tools, the wrenches and screwdrivers of our toolkit. But for some very specific jobs, there's a power tool, a specialized formula that just cuts right to the answer.
And here it is. I know, it looks a little intimidating at first glance. But trust me, if you ever see a limit that fits this very specific pattern, x to a power minus a number to that same power, on both the top and the bottom, you can skip everything else and use this formula to get the answer directly.
So, how do we actually use it? Let's break it down. Look at the problem on the left. The first step is to recognize the pattern. You have to realize that 32 is really just 2 to the 5th power, and 16 is 2 to the 4th. The moment you see that, it all clicks into place. It perfectly matches the formula, where n is 5, m is 4, and a is 2.
And this is the payoff. On the left, you can see the problem being rewritten to fit that pattern, and on the right, the formula is just applied. The exponents n and m become the fraction 5 over 4. Then we have our a, which is 2, raised to the power of n minus m, which is 5 minus 4. The calculation from there is simple, and it takes you straight to the answer. It's incredibly fast.
So there you have it, your complete starter toolkit for solving limits. You always, always, always start with direct substitution. If that lands you in 0 over 0 territory, you check to see if you can factor. If there are square roots in the mix, you use the conjugate method. And if you're lucky enough to spot that special pattern, you can unleash the power formula.
So the next time you see a limit problem that looks impossible, just remember, you're not stuck, you're a technician with a full toolkit. You can diagnose the problem, and you know exactly which tool to grab to solve it. The only real question is, which one will you use first?